Hi, welcome back to DevOps course series. This is Satyadev. In the last presentation, I talked about DevOps. I defined DevOps. So then I also talked about what is Dev, what is Ops, what are their activities, who constitute Dev team and who constitute Ops team, and how they collaborate each other. We have seen the DevOps workflow also. Now, in this presentation, I'm going to talk about DevOps principles, practices, and tools, because when I was defining DevOps, this is what I said, like DevOps is a set of principles, practices, and tools that aim to integrate software development, dev team, and IT operations team to improve collaboration and increase deployment frequency and deliver high quality software faster and more reliably. So I have already explained about dev operation team, how the deployment happens, what is high quality code and all that stuff. I just touched upon, but I haven't talked about what are DevOps principles and what are the DevOps practices and what tools are used to enable the DevOps practice, which is what I'm going to discuss in this presentation. Let's move on to the next slide. So this is what I told, like, dev and ops team works together in a infinite loop kind of way. So team should be aware of ops should be aware of dev. This is actually a foundation for their DevOps principles and practices. So again, what are DevOps principles, practices, and tools? Let's dig further. Now, these are the fundamental principles of DevOps. One is customer-centric approach. What it means: align IT department, which we have seen what is IT department, and development effort with business needs and user satisfaction. So whatever dev and ops team does, it should be towards the end goal that customer needs, right? And encourage rapid feedback from customers by following lean and agile iterative development model, which is what we already have been discussing. The second principle is collaboration and shared responsibility, which actually shown in the DevOps workflow. Shared goals. They should have a shared goal. I mean, when it comes to releasing a product, if dev team has one timeline and ops team has another timeline, that doesn't work together, right? So they have to have the same goal, same timeline and goals, and they should have the ownership. Both teams should own the product. It's not like the software is dev, so ops team shouldn't take it in. They have to work hand in hand. And teamwork among dev and ops and other teams such as security, quality assurance, etc. through open communication. Again, open communication is agile philosophy, but when it comes to ops team and dev team, agile doesn't say anything, but DevOps comes into picture and it says yes, collaboration between dev and operation should be there, and they should share their responsibility. Continuous everything. There are 7 continuous things, like continuous planning, which actually highlighted in the DevOps workflow, like continuous planning, continuous development, integration, deployment, testing, delivery, monitoring with feedback loops. So these things should not be like unlike in waterfall model, they should not be like siloed things. They should be continuous planning, development, integration, deployment, testing, delivery, monitoring, feedback, and again planning. Like that, development, like that should be keep on going on. It's like there should be an infinite loop until the product is delivered successfully to the customer. Then infrastructure as code, IAC. I already explained in the previous presentation. Managing and provisioning infrastructure. Infrastructure means like hardware, network, virtual machines, load balancers, etc. Using code and configuration files rather than using manual process. It's basically what it means is if you want to have a 8 GB machine with i7 processor with 1 terabyte hard disk, then I should not be going like I want this, like manually building that. Should be done automatically just by saying some script file, give it to the cloud, and it should build everything and give it back to me. So they should take care of writing those scripts and stuff like that. The next one is automation. This is one of the big things that is missed in the agile thing, right? So automation basically means like automating repetitive and manual tasks in development and deployment process. It's not just development, like automation for when it comes to development is more like a QA activity, whereas when it comes to deployment it's more of ops activity. So again, even developers also has to do automation in terms of writing the unit tests and stuff like that. So DevOps, one of the strengths of DevOps is to automation. And the third one, security integration, embedded automated security practices within development rather than treating them as a separate field. So security should be integrated as part of development. In the olden days, they used to write the software, then they start working on the security. Now with the DevOps and Agile working together, security has to be the first citizen of development. Like it should be part of development activities. So making sure that we shouldn't expose unwanted ports. We shouldn't have any memory leaks and those kind of stuff, right? So make security issues, which I'm going to talk in later presentation. Measurement and logging. Now, what is measurement? Like how the software is working in the production? Is it really working fast as per the expectation? Because with the cloud environment, customers are expecting like the downtime in terms of percentage. Like the software providers or the product providers says the software will like 99.9%, which is like a 3 nines thing. Like 99.9 is 3 nines, right? Thing. So that means only 0.1% it could fail. So that kind of and is it really happening that way? It's not just saying, you should have a proof, right? For that we should have measurements, uses of metrics and logging that shows that yeah, this is working as expected or this is failing here, and monitoring to ensure visibility and performance and accountability of the. So these are basically DevOps principles. Now, aligning to these principles, there are certain practices followed by dev team as well as dev team. When I say dev team, it's not just the developers, it is dev, QA, UX, those guys, like all the technical people, dev team as well as the ops team. Version control. The first thing practice is version control. So one of the practice that DevOps strongly suggests, which Agile doesn't have any input, is you should maintain a common version control. So what it means, like manage code changes in a centralized repository, enabling collaboration and tracking of changes. Now, there are several tools that are there available. Git or JIT, whatever it is. So is one of the things. Now, GitHub is nothing but like a provider of Git. And GitLab is also like that. GitLab is also like that. But I'm going to only talk about Git as a separate series. So the things that I'm going to talk about in the future series are highlighted in green. Then again, continuous integration. This is one of the DevOps practices. Automatically merging code changes and testing to ensure stability. Now this requires a build server. And there are several build servers available: Jenkins, GitHub Actions, GitLab, CI/CD, Client CI, and so on. So there are so many things that are available. So in the next series, I'm going to talk about present about Jenkins as a build server. Continuous delivery, extending continuous integration. Basically, integration means combining code from multiple developers into one central repository, and once they are combined, be tested automatically and make sure that everything works fine. Continuous delivery means once that build is done, that whatever that is built is called the artifact. That artifact should be deployed into some place and delivered to the where to QA or user server so that they can deploy into a machine. Extending CA by automatically deploying code changes to a staging or a product-like environment after passing tests and enabling frequent reliable release. Again, Jenkins also plays this CD server. So I'm going to discuss Jenkins. Apart from Jenkins, again the same thing: GitLab, CI/CD, Argo CD, Octopus deploy. There are so many things are there. Continuous deployment, automatically deploying every code change that passes test directly to production, minimizing manual intervention. Now CI is like for developers. CD is from developers to the build machines, test machines and stuff like that. From continuous deployment is like putting it into the production. Again, the same set of tools that are prescribed, Jenkins, GitLab and all that stuff. I'll talk about Jenkins later. Infrastructure as a code. again, as I explained multiple times in this previous presentation, um, getting infrastructure like servers, networks, and all that stuff should not be like a manual process. It should be managed infrastructure through code or scripts, enabling automated and repeatable provisioning and configuration. There are certain tools that are already available like Puppet, Chef, Ansible, Terraform. So these are all the things that I'm going to discuss in the future presentations. AWS has got cloud formation, which I'm not going to discuss, but this is also available. So these are some of the practices and tools we pay. The other practices are configuration management. Ensure systems are consistently configured and maintained and automating updates and compliances. Now again, the same kind of tools can be used like Puppet, Chef, and Ansible, which I'm going to discuss later. Another important thing is containerization and orchestration. Now, virtual machines is a concept that's there since 2000, but virtual machine has got some problems and challenges, which are actually solved by Docker really well. Docker is a container, is a software which comes under the category of containers, which I will discuss as a separate series, where it packages application into boxes. Container is nothing but a box, right? For consistency and across different environments, and orchestrate them to scalability. Orchestrate basically means like managing. So for that, I'm going to talk about Docker and Kubernetes, which will be another set of series. And automated testing like JUnit, or using JUnit by developers, unit testing, integration testing, regression testing, performance testing, all those scalability testing, all those things, like to ensure that code is quality is through the CI/CD pipeline is really good. Again, JUnit for developer. Selenium I'm going to discuss. And Postman is basically a wonderful tool which can be used by developers and QA team, just to make sure that their web application or web services or web APIs are working fine. So that's for I'm going to discuss those things in the later presentations. Continuous monitoring and observability tracks application infrastructure performance in a real time using metrics, logs, and traces to detect and resolve issues. So basically log, and there's a difference between log and traces. Log is basically from one component. Trace is like throughout multiple components how the things are flowing. That's the difference between log and trace. Again, Prometheus, Grafana, Datadog, Elk basically means Elasticsearch, Logstash, and Kibana. These three work together. They're called Elk Stack. Work together. I'm not going to do any presentation as of now. I'm not planning any because they are not part of this course series. So continuous monitoring and observability is another aspect of DevOps practice. Collaboration and communication. This is more like a people thing, not like a technical thing. Again, but they facilitate teamwork and transparency among development and operations and other stakeholders. So one of the popular industry standards is like Jira. Jira is for creating stories or features, for the product. Basically, Jira used for documenting product. Okay, this is what I want for this quarter to be done. That's like a big one thing. In this, divided into several features. Each feature contain different stories. Different stories contain different, units of other work. So like that, Jira organizes things, the work that needs to be done for software development. Confluence, more like a documentation system for the software product, where they can collaborate and work together. Slack, which is like a WhatsApp group where you can communicate. Zoom is like a video way of communication. So these are basically Microsoft Teams. So basically software that facilitate teamwork. And then is continuous feedback and improvement. Use feedback from users, stakeholders, and monitoring tools to drive iterative development. Again, Jira can take place, Confluence, Sentry, SurveyMonkey. SurveyMonkey is another one actually, which is really good, which takes the feedback from people very quickly. It's like a Google form. basically. So these are the tools. And when it comes to security, there are several tools: SAST tools, static analysis, right, software tools, and dash tools, dynamic code analysis, right. Basically integrate security practices into DevOps pipeline, ensuring secure code infrastructure from development to deployment. Like I said, there are several tools: checkmarks, OSAP, like JAP, like Dash. This is a Dash tool. Sonar Cube, Aqua Security. These are all various tools that are. Again, this as of now, there is no plan for making any series for those things because they are not part of the course structure. Cloud computing, hybrid deployment, hosting and scaling applications seamlessly. AWS, Azure, Google Cloud, OpenStack. Alibaba, several things are there like in the cloud environment. Again, as part of this thing, I'm not planning to do any cloud related presentations. I think that's pretty much it about practices and tools, principles, practices and tools that are followed by DevOps. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.